Okay, so the question that was raised is, well, the next thing you're asked to do on a typical problem is sketch the line that you think fits the data points somewhat better, right? Well, if I raise this line without changing its slope just a little bit, okay, I move a little further from these points, but a little closer to these, right? Okay? And that's going to have the effect of improving the sum of the squares of the distances, okay? It might not improve the average deviation, but it might improve the sum of the squares of the deviations, as we talked about last time. So you can go back and kind of review some of the videos from last time if you want to be sure you understand that idea. Now, what I really want to do is find something I can stretch out between these points. Okay? So, what do you think of that line? Think that's pretty good? Think maybe it needs to slope just a little more to get a little closer to this point up here? We don't need to be all that close to this one. I'm thinking about there. So I'm thinking about a point from around here, a line from around here to around here. Let's see if I can draw that. And I messed it up. I drew it too high. Okay? But really, I wanted to go through this point and this point. So I should probably fix that a little bit by making a line pretty much parallel to this. But a little bit lower. Then we can do a couple of projection lines to estimate the coordinates of this point and the coordinates of this point. This point looks like it's about between 1 and 2, about 3/2, and it's pretty close to 6. This one looks like it's about 12.5. That'd be 25/2, right? This point up here. (25/2), and I'll say that's about 17. Y'all understand what I did, right?
Yeah.
I sketched a line that I think does a better job, okay? And then I picked 2 points on that line. And now, with those 2 points, I can find the equation of that line, okay? And the green line we can ignore because that was my attempt to go through this point and this point, and somehow I just ended up about a ½ inch high on both of them. Just my own ineptitude. Okay? Now, I don't think that's the best line. I think the best line probably has a little less slope. Comes out a little lower here, maybe a little higher here. It's going to be good enough. Okay? So, what's the equation of this line? Well, now I could draw the fundamental triangles, and remember you have to be able to do that because you will be asked. Okay? You know, this fundamental triangle and this fundamental triangle. But just for brevity and to get this done somewhat quickly, I also know that the equation is y minus y1 equals m times x minus x1, right? And a fundamental triangle from this point to this point is pretty easy to draw. I have to go through some of my writing. So ignore the fact that I'm going through the word ignore. There's a fundamental triangle, right? It's got a rise of what? Y minus 6.
17, so that's 11.
Over x minus 3/2, right? Now clearly, if these 2 points are on the line, then that's going to be its slope. Okay? You don't need a formula, you just need to be able to draw a fundamental triangle. Okay? Although if you got a formula, you want to use it and use it right, fine. But if you can draw a fundamental triangle and choose to use a formula and screw it up, I'm not going to grade it as leniently as if you've done the fundamental triangle and had a simple error on that. Okay? So, okay, so you have this, and you know that's dumb.
Okay.
Yeah, it's not y minus 6 over m minus 3 halves. I'm doing a different triangle in my feeble head. It's 17 minus 6, right?
Yeah.
Divided by 25 halves minus 3 halves, which is 11 over. Oh man,
Oh, man.
I don't like this.
Well, you
Anyhow, it's
can
11 over 11, which is 1, and it's the same slope as this line, but it can't be because it's clearly not parallel, is it? That just shows you I can't draw. Okay? So just coincidentally, with honest estimates, we got the same blame slope. Yeah, that's all right, we're just demonstrating. That usually won't happen. Don't expect it to happen, and don't try to make it happen, right?
Oh.
Do an honest estimate, and if the universe is so perverse as to make this slope come out the same as this one, as long as it's an honest estimate, I'll have to tolerate it. Okay, now, we put that into here, we get y minus, okay, I'm going to use this point, y minus 6 equals 1 times x minus 3 halves. That gives me y equals x. Okay, minus 3 halves plus 6, which is 8 halves. That's going to be plus 5 halves, 2.5. That can't be right. It's 12 halves. Gee, man. Get the wrong number in my head, right? Okay, so, you know, that's 12 halves minus 3 halves. It's 9 halves, which is 4.5, which isn't too bad. There's 4. There's 6. Well, that's closer to 5 than 4.5, but at least makes reasonable sense when you consider that the graph was drawn by hand and I'm looking at it from this angle, right? Okay? So, we have the equation of the line. Now we want to find deviations.